import and import linealg from NumPy NumPy as lin. So you can write this, import linealg module from NumPy, or you can write numpy.linealg, or you can also write numpy dot linealg as lin. You can write that. Okay. So in that you will find this in this linear algebra module. You will find everything about metrics. Someone was asking yesterday the determinants. Suppose I make a two-dimensional array, kind of matrix. So I can write to say np dot say random dot say randint. Say I want to create numbers from 1 to 10, and we can make it say 3 by 4. Okay, so this. So my matrix is, the array is this. So if I now write lin is the module. Lin is the module now. So inside that you have just date. I was looking for not date. I mean first I rank date. I'll tell you why it is not doing the date. Lin. So it has a. I think it has I checked the function name is matrix dot rank and then a. So it will the function name is matrix underscore rank, and inside that I put a. Well, so this rank of the matrix is just created. I just created this array. You can think of it as a matrix. So the rank is this. And of course, why it did not calculate determinant, you understand that because it is not a square matrix. You have to, because determinant is always for the square matrix. So that's why it didn't do. If you write the same thing probably with say 3 by 3, and this, and now you write lin dot date dot inside that you write a, and it will show the determinant. Well, okay. So this is I wanted to this I carry from yesterday, the answer to the question. At that time I did not have in mind. Okay. So let us begin today's work. Yeah. Okay. Please tell me if you do not cannot listen or cannot see, because I am not very conversant yet. Okay. This was, did I talk about this? 6, 7. This is 7. Let me 7. I talked. Let me talk about this after this. Okay. Just a moment. Just a moment. It will take some time. I think hearing and seeing no problem, right? Please tell me if you.
No, sir.
Cannot.
No, sir.
Okay,
It's
okay,
okay.
okay.
It's okay.
Okay. So let's see what where we stopped yesterday. We talked about NumPy array yesterday, and the NumPy arrays and other modules in NumPy, and then some optimization module in SciPy for curve fitting we did. So today we'll discuss about Pandas. Pandas is panel data. Okay, panel data means basically the data that are in structured form. Okay, so these little kids are from Purulia. I took their photos. It's very lovely kid. So in the background, okay, Pandas. So the Pandas, like NumPy deals with NumPy arrays. Particularly, this does very well. NumPy arrays means I mean that's the very basic, and Pandas is another package which is also mostly based on NumPy. So NumPy is the father of all packages. So, but Pandas deals with the tabular data, structured data. Well, so for data science, if you want to do some work in data science, data management, data handling, big data, whatever people say, you have to go through Pandas. So I give a little introduction of Pandas today. Okay. So Pandas deals with the following 3 data structures: series, and the data frame, and panel. You note the names. Series, actually this names come in this form. Series means is a capital S, data frame capital D, capital F, and a panel capital P. But we may not discuss about panel because in earlier version of Python, that means Python 2, these three things are there. But the new version, latest the Python 3, this panel is dropped. For some technical reason, I can suspect what the technical reasons, but if you want, I can discuss all three. But among these three, the most important will be the middle one, data frame. So let me go one by one. Okay, so these data structures are built over NumPy arrays. So you can see that NumPy arrays is really kind of the basic. So about series. So to start with, so what we'll do that if you have not pandas in your platform, in your basic NumPy, so you have to import. First, you have to install pandas. The way you installed NumPy, Matplotlib, SciPy, etc., etc. The same way you first install pandas. Or if you are working in Anaconda, then pandas is pre-installed with that. So Anaconda is basically a distribution. Okay. So pandas is there. Okay. So import pandas as short name PD. So this is a common nickname everybody uses. Okay. So now let's see what is the inside the directory of PD. So I'm not showing for there will be lots of things. Okay. Lot I will show it later because it is in PPT. So I won't go out of PPT at the moment. So it will be concentration will be broken. So anyway, so first thing is that if you import some package like pandas or whatever first time in your life, so it is better that we always, it is a good habit that we always see what is there inside. So I can write dir directory, inside that you write PD. So it will come pages after pages. So you can check what are the functions, classes, arguments, everything are there. So, and also we need NumPy to create data, manipulate data. So import NumPy as NP, it is also important. So I created an array x equal to np dot a range 10 to 50, 10. So that means it will create numbers from 10, 10, 20, 30, 40 because it won't touch 50. So now this thing, this X, this array, if you put inside this PD dot capital S series. So now the series is basically a function. So inside that you put this argument X. So now see the result. So you got this kind of 2D kind of looking thing. X was the 1D, one dimensional. So it's one dimensional array, but you put it inside series. So what you notice is that our values are 10, 20, 30, 40, and the indexing, these are the indexes. 0, 1, Python always starts from 0. So the 0, 1, 2, 3, this indexing is automatic. So automatically it has given an index, and you think it is looks like a kind of table. Okay, already, but we'll see later. And the data type also it will say by default integer 32. That means every integer will be treated as a maximum 32-bit thing. Okay, so now I create a list where inside that I write quote unquote A, quote unquote B, and CD. So you already know these things are basically strings, just like A, B, C, D. These are strings. Anytime you want to write any alphabetic characters, so you have to put inside two inverted commas so that it is a string. Otherwise, your machine will object. It won't understand what it is. Number, it always understands. Okay. So this list, I call it say index itself. You can give any name. You can give here any name. So index equal to this. Now, inside this PD dot capital S series, you put this data X, comma, index. So I told you that if you go to the this array, these interpreters, and you type help, inside that you write PD.series, it will show you what can be the arguments, what can be the keyword arguments like these and all that, how you can use series function. So suppose you study yourself and see what is there. Now for the time being, for the simple introduction, I can just tell you that you have to give first thing, by default argument is the data that we created on the previous page, and the index, you are now forcing this index ABCD. So now you type S or print S, it will show you. Now the in 0, 1, 2, 3 are replaced by A, B, C, D. So that you are forcing this indexing system. So that now you go one step forward. So you have this data and you have the index. So you can arrange this data in this style. So this is a structured form. Well, so like NumPy arrays, you can also look at the what is the index, what is the 0th element. This is 0th element, this is 1th element, 2, 3, and so on. You can also slice, you can also index like exactly like NumPy arrays. So that's why I'm telling that NumPy arrays is very, very fundamental and very basic, and therefrom all the other kinds of functions and structures are formed. So if you write S0, of course you understand, so it will result in 10. If you write S, but inside that you call by index. So my index is now A. So you call by inside the square bracket, you write quote unquote A, right? If you could type simultaneously, you could get the fun. Otherwise, maybe later you will consult this and try yourself. But anyway, don't worry. Everything is in the, I will just give you a guideline. Everything here is in the help, the manual. So, so nothing to worry about. So SA also the same thing. Now the methods, you see for the NumPy arrays, you applied very many methods like sum, len, CumSum, STD, standard deviation, these variance, etc., etc. Lots of methods you applied on NumPy arrays. So similarly here also for series also you can apply lots of methods. Like you can write s.access. Since you refer S, because S is now our series. S is now our series. This is the S. So S is the series. So the access is a function, but if you tag it with S, you do not have to write the first brackets. So you write s.access. That means access becomes an attribute to S. It's like our attributes. Our surname can be our attribute, or our prefixes, Mr., Dr. All these are attributes. So s.access. So it will give you the information about the everything range index. So it tells you talks about the index range. So index starts from basically 0, stops at 4, and step 1. That means 0, 1, 2, 3. It gives you the s dot values. This is another attribute. So it will tell you the values. Suppose you got a series data from somewhere, you can immediately write s dot a values. So name of the series is say s, and then you can write s dot values. So it will show you the actual data. I mean, it will clear out the index and everything. It will show you as a array. Okay, and the data type here, a data type it is showing integer 64. You will just check. Don't believe me. You check on your computer what is the data type it shows. Sometimes in some machine it will show integer 64, or in some other platform it can show 64 or 32. It depends on the machine and the platform where you are using, what you are using. So s dot size, there are 4 data, so s dot size is 4. S dot shape, of course you have 4 data and it's a one-dimensional data, so it will show you a tuple. This is a tuple where tuple comes with the 2 the parenthesis and something with comma. So something 4 comma, that means 4 items, and comma means there is nothing, means one-dimensional, just like NumPy arrays. S dot ndim, all the NumPy array methods we are using here. So dimension is 1, so it's a dimension 1. In terms of, we call it vector in physics, 1 dimension, and 2 dimension we call automatically matrix. Anyway, so s dot d type, so it is showing integer 64 because it already showed here integer 64. D type is data type. So you could call a. Acha, now see, we have. Oh, sorry. We have, okay, we have the data 10, 20, 30, 40, and we have the indices A, B, C, D, right? So now if I write SE, E was not there. You just write S under within the square bracket E this thing, and we give a value. That means it will automatically understand that I want to add this index, and the value is 50. So the new row added. So now if you type S, and it will show you A, B, C, D, E. So that way you do not have to append or something. You just write this. So this works for list also, array also, if you check it. Okay, now we give data in the form of some names, say Raman, Guido, Ismail, and Oppo. By the way, Guido is the man who created Python, Guido van Rossum. So he's the man from Netherlands, very young, and he actually created this Python, and now this is revolution. Anyway, so it is 4 names. Now this is your data now. So you write pd.series. Inside that you put this data, and the data will be these 4 names, and the indices will be 0, 1, 2, 3 because I have not forced index here. And the data type, it says object. Whenever the data are in alphabetic things or in strings, it will tell that the data type is object. Well, data as scalar. So suppose you write index equal to ABCD, and the pd.series, you write only one data, say 10. We are not writing a list or something. We are writing only one data point, 10. And now we are forcing this index where the 4 items are there, A, B, C, D. And we also can call the data type is int. We could write d type equal to int, but also if you write the int, it will work if you write them systematically, order wise. So now see the your series is this. So that means it is so clever that it thinks that the index is 4, ABCD, 4 items are there, but the item, the data is only once. That means we call it a scalar. That means the scalar is repeated, 10, 10, 10, 10. And since we have said here int, so data will be placed as considered will be integer 32. So this is sometimes you work with series and something arrays, some common sense will work. We understand the Python is so clever that if you do something, so if it is doable, it will do. So it understands that you want 4 indices. But now, what is this? This is a dictionary, series from dictionary. I hope that you know dictionary. Dictionary is you have understood, you have known list, you have known tuple, even in my talk several times. And now this data form is called dictionary. Dictionary is written in this way. In fact, basically in Python, of course in C and C++ also. So in Python, we have a system of expressing the collection of data in various forms. In Python, it is series, it is list, tuple, dictionary, set, and all that. Okay, in basic Python. So in basic Python, dictionary it starts with a curly bracket. So we call it second bracket. So curly bracket here, and inside that, this is the whole item separated by comma. This is next item. This is next item. This is next item. But inside that, dictionary means what? You consult a dictionary means we want to see some word, and we want to see what is its meaning. That means in terms of computer language, the word we search, that is a key, and the meaning that is there, that is the value. So basically here, this is I write quote unquote A. It could be anything. Since it is an alphabetic thing, we write within quote unquote. So this is a key. This is key, and this is value. This is another key, and its value is 20. So basically, we mean that A's value A is equal. A corresponds to 10, B corresponds to 20, C corresponds to 30, and so on. So this is your form of dictionary. Okay, now I think we input this data in the form of dictionary into the series, right? So you see, you don't have to write your indices because now the keys A, B, C, D, these are the keys, and the keys act as indices A, B, C, D. So that's one interesting thing. Either you could write pd.series inside data, comma, index, and things like that, or you could form a dictionary beforehand, and you could put inside the as argument inside the pd.series, and you get this series format. And of course, it is integer 64. So basically, uh, I mean, you can ask why I will go to make a dictionary. That's not that's a question, but you can also think that you can get data from somewhere else, and you such a way you convert data in such a way that you ultimately you get back something like a dictionary. Then you think, okay, that is my data, and I can put it into series, and it will arrange the data in such a way. This is an arrangement, structured form. Well, now I impose dictionary, now index. See, I have now I want to put index over it, but now you see there is a difference. I put the index A, B, C, D, but one extra E. I didn't know what is the inside the data and things like that, but now I think I put the index A, B, C, D, E. Okay, now see what happens. A pd.series, the data and the index. What it will happen, because inside that we have 1, 2, 3, 4 data. We added one data. Okay. Okay. Any question? Any Atanu? Okay. So now what happens is that you get this. You see, the important thing is the last line. A, B, C, D. All the data are, I mean, is copied here. 10, 20, 30, 40. Of course. One thing is that the E. Look at E, because E was not here in the dictionary. The data is only 4, but we are forcing there should be 5 indices. So in the fifth index E, can we you hear or something, some problem? You hear or some problem? Let me check my connectivity. Okay. I think I might charge yours. Okay. Now. Okay. Okay, I think it's okay. Okay, now you see this important point is that the fifth data, see, there is a NaN. NaN means you will encounter this thing in many times when you import data from outside. NaN means the data NaN is actually not a number. NaN is not a number. So that means wherever it did not see any data, that means there is a missing data. So Python will fill it up with something. It won't keep blank. It will write NaN. So that is one thing you should keep in mind whenever we deal with data. Suppose you are having an Excel sheet. You are putting data of every person's, hundreds, thousands persons, and all the attributes like name, age, date of admission, etc., etc. But for some people, the date of admission is missing. So you keep blank, and now you want to import this spreadsheet through mechanism, and you convert it some numpy array or whatever, or series or whatever. So the Python will automatically create the missing data as NaN. So that's what you see. And it is so clever, it does not know what will be the form of the fifth data. So fifth data doesn't know, but you have given the data in the form of integers. So 10, 20, 30, 40 integers. So it has assumed the fifth data may be in decimal points or float, we say. So it has actually forced everything as float. See, 10.0, 20.0, and so on. So this is very kind of educative in a sense. To begin with, you have to remember that this happens. Actually, Python does it well. So your series is this. For example, if your series is 20, 30, 40 original series, and now you can manipulate the series. You can write S star 2. If you write that like a numpy array, so every data will be the product of 2. Say 20, 40, 60, 80, write that. So if you write np dot square root of S, S is series, but it looks like it acts like a square root is the function from NumPy, and it is vectorized. So square root will be applicable for on every item, like NumPy array. So it will give you this ABCD and the square root of all the items, 10, square root 10, square root 20, and so on. And the now the data type is automatically float 64. Earlier it was integer 64. Okay. Now if you write np.sums, of course it will sum all the elements. Now if you write np.minimum of s, so minimum, it will give you the minimum value. If you write np.max, it will give you the maximum value. So these things will be sometimes useful. Suppose you have got some data and you got a series, and it's a big series. You want to know what is the minimum value, what is the maximum value, etc., etc., for your own data manipulation. And this is also slicing. You yesterday you saw for NumPy arrays. If you write 1:3, that means it will take the 1th element, then 1 and 2. You don't touch 3. So it is B corresponding to 20, C corresponding to 30. So it will fetch these two items. If you write s.sum, of course it will be 100. Either you could write np.sums or s.sum. This. If you write s.mean, it will of course, like yesterday, it will give you the mean of the items 10, 20, 30, 40. If you write s.std, of course it will give you the standard deviation, etc. So this is the end of part 1 Pandas. Now we go to the part 2. Now we go to where it was, 8, and this is a 9. 9. Please ask a question if you have, please. Okay. Okay. So slideshow beginning. Okay. So this is Pandas part 2. So of course here we will discuss about data frame. So we have learned about series and now data frame. Okay. So import Pandas SPD. And suppose we give data, either list or an array or whatever, 10, 20, 30, 40, say, just for demonstration purpose. And you write pd.dataframe. Remember this capital D, capital F. And inside that you put this data, this argument. So now you see like a series, it has produced 0, 1, 2, 3, 10, 20, 30, 40. But notice here it has put 0. That means these are the row indices, 0, 1, 2, 3, and this is the column index. So the data frame is one step above. That data frame is one dimension above. So in the data frame, you have a provision of more than one columns. So really we are going towards the table. So basically the column, it has by default, it has written 0. Okay. So now you have a data. The data is now 2-dimensional. See, in the series, the data was 1-dimensional always. Now in the data frame, we can think of putting a data in the 2-dimensional way. So it's a 2D list. I'm not intentionally putting array. You can put an array also, 2D array, no problem. Array or list looks same. Okay. So it is a 2-dimensional array. Basically, if you write like a matrix, it is one row and the next row. Anyway. So if you now write pd.dataframe, inside that you put this data, say D. So now see this row, see one item is this 10, 20, 30, 40. So it is 10, 20, 30, 40. Next item is 50, 60, 70, 80. So the 50, 60, 70, 80. So these are the two rows, as you can assume, as you can imagine, this has to happen. So the row indices are 0 and 1. But now you see the column indices 0, 1, 2, 3. So now you have a frame really where it's like looks like a table where you have the columns and where you have the rows. But now they are automatically designated. Now you go one step forward. Now you see you can write, say you can force index equal to A and B. And you write pd.dataframe D, comma, index. That means, of course, you can understand the indices were 0 and 1. Now the index is always for index. The name is for always. This name index keyword is always for rows. Okay, and these will be called columns. instead of rows, they call it index. So the row index is index. So the now the data frame is this little better. You have the indices A and B. Okay. Now you can write pd.dataFrame, and of course I have given the same name, doesn't matter. I have given the data D that I created, this data, and the index is this, and then now the columns also I write columns. This columns is keyword. Columns equal to A, B, C, D with inverted commas. All these 4 strings. Now you can understand. So you have this data frame where you have renamed the rows and renamed the columns. So the columns are A, B, C, D. Rows are small a, small b. So this is your complete data frame. So in the complete data frame, so you can understand that the data frame is a truly 2-dimensional object, and the structured form of data is like a table. Okay. Well, so the data frame is this, and now you can for like the series, like in series or in NumPy arrays, you can always have in this indexing, you can always have slicing methods and everything. Here also for data frame you can do the same thing. So that's what I was telling, that it's nothing really very kind of complex things. You get to know one thing, you will get to know everything. So the philosophy is like that. I mean, the same philosophy works for everything. So D, you can call D, and inside that you write A. A means this column, of course. This A with quote unquote. You want to have this column. What is the A column? Okay. See, the column is 1050. So 10, and the indices, those row index A, B are already automatically given. If you now call D of A, this object, this is now this. Inside that, of this, you can think of this D of capital A, you want this small a. That means it's like a coordinate system. Capital A, small a. So out of this, you want this small a index corresponding to what is there. So all you write, you have to all write in a square bracket. So obviously the answer will be, you know it, the answer will be 10. So this way you get to find out what are the elements. You have a big array. Now after a while I will show you with the real data. You have a big data, the data huge kind of data frame, or a huge spreadsheet which you cannot see at once on your screen. It doesn't fit your one screen, but you want to know what is in that column and that row, something like what is under this name, corresponding attributes and things like that, corresponding values. So this is very helpful. These methods are very helpful. Okay, so methods over frame actually. So the methods we applied for series and series and NumPy arrays. So I will not go through detail of this because lots of methods are there. You can go and check help pd.dataframe. You can check help. So it will, if you write d.access, D is my data frame now. If you write d.access, so it will show you the access. If you write d.size, it will show you the size. Size means how many items are there. If you write ndim, the dimension of the data, it will show you. If you write capital T, that means like a matrix, like a NumPy array, it will actually transpose this. That means here in this data frame, rows will be columns and columns will be rows, which sometimes you want to do. D.empty, this is another method. You go and check what's there. D.values, the values it will give. This is very important. I will use that. Suppose you have a big data frame, huge data frame, and you want to see what is there, how it looks, but you don't want to see everything because that it will clutter your space and you cannot see in your screen. It will be size will be very small, or you cannot scroll up down many times. So you want to see the head only. Head means by default it will show you the 5 rows by default. But if you write d.head, inside that you write some 10, it will show you 10 rows. I'll show you. Similarly, it will show you the tail. So head is there, tail is also there. So you want to see the tail portion of your spreadsheet. Okay. And of course, whenever there you write this function, inside that argument, you can write something. If you do not write anything, it will assume that you want something by default value. So similarly, you can write d.sum. And also if you write d.sum1, you understand from yesterday's experience that it will sum over the axis 1. Okay, and this is by default. It is total sum. And this is the sum over axis 1. Axis 1 means it will go in this direction. So it will sum over a row. These things you do in Excel sheets, of course, always you do. But the point is, why then we'll learn this, of course. That's because Excel sheet has limitations. If you convert the Excel sheets into data frame, and then you have the arrays and things like that, and you can handle it better, you can plot it better, you can manipulate the data better, you can do modeling, and you can write programming and things like that. So that's why it's always better to convert Excel sheet to your known thing. Okay, so you can also write d.mean, and also d.mean 1. 1 means 1. This, if you write this 1, that means axis 1, and again you write 1. The first, I think it will be the first row, like something like that. You can check it. d.std, d.std1, axis reference, standard deviation, d.max, d.min, etc. And this is, I just want to tell you because these all are things are there. So you can go there and check. So whenever you got a data from table from somewhere, and you know that is a data frame, and you can check all these things before you go into detail and modeling. So if you can check the data set. What is the head? I mean, what are the first few data? What are the last few data? Mean, standard deviation. The preliminary observations you can do with this. And also there is one method that is very important. If you write d.describe this thing, you don't have to write anything first. It will give you the full statistics. That means it will give you a table where it will say mean, median, mode, sum, cum sum, etc., etc. All these things it will give. So describe is one method. At one go, it will save your time. Basically, it will save your time. It will give you all the statistics at one shot. Well, data frame you have to create. You can create data frame from dictionary, like you created series from dictionary. So now you write the data in the form of a dictionary. A corresponding to 10, B corresponding to 20. That means A, B, C, D are keys, and 10, 20, 30, 40 are values. So, and you now write 1, 2, 3, 4, the index, and you write pd.data frame, data comma index. So obviously you will get this data frame. Here these index is 1, 2, 3, 4. So it will write 1, 2, 3, 4, and these are the corresponding plots A, B, C, D. Okay, data frame from dictionary of lists. So its complication increases. So your data is, it is a dictionary. So it's a curly bracket here and curly bracket there. That means it's a dictionary. But the one item is, this is the first item separated by comma. So this is the key A, but the corresponding value is not a single value. It is a list, 10, 15, 20, 25. Again, next item, B is the key and the colon, and the corresponding value is this list, and so on. So if you have this data in this form, this is, you can think of dictionary made of lists. That means the dictionary where the values are the itself, they are the lists. You can actually prepare dictionary of dictionaries, dictionary of lists, list of dictionaries, dictionary of arrays, all kinds of things. Because if you can do juggling with the kind of these data structures and data collections, you can do anything. It is a question of presenting data and deciphering something from the given data. So if you are you kind of used to it to manipulate the data, you will be fine. Okay, so index is 1, 2, 3, 4. and you now write pt.data frame, and the data is this. Remember, the each value is 10, 15, 20, 50 as a list. And now you give index. Oh, okay. So the index is 1, 2, 3, 4. You are forcing 1, 2, 3, 4. So index is 1, 2, 3, 4. And the obviously the keys will be the columns: a, small b, small c, small a, small b, small c, small d. And now you see the whole list goes as a column: 10, 15, 20, 25. 10, 15, 20, 25, and then 30, 35, 40, 45, and the next column, next column, next column. So you understand how you go a little bit more complex, and but you ultimately you have to get back one data frame. That is important. But how did you get? In very many ways you can prepare your data frame from the given data collection of data. Okay, data frame from the ulta list of dictionaries. You had dictionary of lists. Now you have list of dictionaries. Okay, let's see what. Yeah, data is, see, this is a list. The square bracket here, square bracket there. So it's a list. Whatever inside doesn't matter. It's a list. But here you see one item is itself a dictionary. The whole item, curly bracket here, curly bracket there. So it's a dictionary. So this is one item for the list, comma, next item for the list, and so on. So each item is a dictionary. And inside the dictionary, you have key X, quote unquote, colon 2. X corresponding to 2, Y corresponding to 10. Similarly, for the next item, X corresponding to 4, Y corresponding to 20, X corresponding to 6, and so on. Okay, so this is your data. It's a little more complicated form. So if you write pd.data frame, and inside that you write data, and then you can also write index A, B, C, D. You can force it, you may not force it, but you see your data frame is this. Index is A, B, C, D. Well, A, B, C, D. And the X corresponding to 2 here, X corresponding to 4 here, X corresponding to 6 here, and X corresponding to 8 here. So they come all the column. Basically the keys, I mean, you have to remember the keys will be the columns. So the X and Y are the keys everywhere. So X and Y are the columns. So it collects the values 2, 4, 6, 8, and then 10, 20, 30, 40. So now the data frame is this. Okay. So okay. So the data frame is this. Okay. Okay. Please tell if you are confused, because this structure is getting more and more complex. Okay, now like NumPy arrays, we can actually try to find out what is under X column. So of course under X column, that is this under X column 2, 4, 6, 8. So it will show you 2, 4, 6, 8, and it will also show you the indices, row index A, B, C, D. And it is also good. It's very sober. So it shows you the name of the what is under X. So name of the column, and it is also declaring that the data type is integer 64. You can now, like the previous series case, you can now write D, X, and B. That means under the X column, the Bth row. That means B row means this. The row which has index B. That means 4. Of course, the data will be 4. So this is how you actually manage to see data frame. Yeah, this is one step more complicated. Data frame from dictionary of series. You can understand that inside already you understood that the data frame is a 2-dimensional structure, but series is more or less basically varying from the row indices that is there. Series is basically 1-dimensional object. So you can think of always that in terms of dimension. So 1-dimensional object will always be embedded in 2-dimensional object, of course. Yeah, on a plane 2-dimensional, you can always draw a line. So that's like that way. So if you have index A, B, C, D, and you have a series. So I rename it as say S1 pd.series, and you create first series 5, 8, 9, 11 say, and you put the index here, okay, and you have another series say S2 pd.capital series, then 7643, and you give the index. Okay, so now if you now write the data in this form, this is the data. So data is a dictionary. So what is this dictionary? Dictionary is has the key A, and the value is the series. See, S1. S1 is the, here is the value of the is corresponding to this key, but S1 is a series. Similarly, you have this B as a key, and the corresponding value is S2. S2 is another series. So basically, your data, this is your data, D. D is the dictionary of series, right? So now you write pd dot data frame, and inside that you put data, and you see type D to see what it is. Yeah, now it is this. See, the indices are ABCD. So indices are ABCD, and the columns, where from it gets the columns A and B. A and B it gets from the basically this dictionary, this data dictionary. So here is A. So the one thing you can be sure that the keys will always form the columns. So A is here, B is here, okay, and the S1 was the data was here, and the index is always there. So the 5, 8, 9, 11. So this is the first column. So first series is the first column. Second series is the second column. Basically, you can understand that if B would not be, this column would not be here, and the column index A would not be here. So this one, A, B, C, D, and 5, 8, 9, 11, this would be a series. Similarly, A, B, C, D, and 7, 6, 4, 3 would be another series. So you combine two series and get a data frame. Similarly, you can combine any kind of series, and you get a data frame. So basically, you can understand that of a table, each column is a series, and the whole table is a data frame. So that is, you construct from a one-dimensional structure to a two-dimensional structure. Please ask me if you are confused, or if I'm fast or slow. Please correct me. Okay. So add column to data frame, right? Now, like the series or the data frame, like series, we can add the data frame. Since you see, we created the data frame in terms of with the help of series. Now I can write D quote unquote C. That means you can understand I want to add another column C. And the column, if you give the column, it will understand automatically. If you give the one column is another kind of series or something. So of course, data frame has to be equal to data frame. Two sides has to match pd.data frame. But inside that you write basically a dictionary of series. See, C quote unquote the column. This is the key. Key will be the column. See, colon and pd.data series, pd.series 10, 20, 30, 40, and then index. So you write this. So basically, you added this column. There is even simpler method, I'll tell you, but you can do that. You want to add a column in a table when you are writing programs and you are manipulating data in Python. So you have to, you can consider this. You can do this way. Is here, and you add this column, because you understand every column is a series. So you have to add a series. So you can also do that. That's it. This is easier. DC, C means you think that this is another column you are adding, and simply you write series. That is also possible. So this is easier. You write pd.series 10, 20, 30, 40, and index. So you get this. The same thing you got earlier. Okay. So that means you can, you now are, I emphasize it again and again, that you now have the two-dimensional data structure, which is data frame, and which is basically a table. And table has any table, it's universal. It has rows and columns. So rows are given by index keyword, and the columns are given by columns keyword. But if we construct through series, we don't have to think of that, because series can be made of something with the either the column reference or with dictionary, where the keys will be the column names, whatever names you give. Okay, we gave ABC, it is ABC. So this is something. Okay, now like NumPy arrays, you can now delete, insert. It has to be, because you have a table. You got the table in the form of data frame, and you can now manipulate the table. You add columns or rows, or etc., etc. You can do that. So D is this data frame, ABCD, capital ABC. And now del, you want to delete is del. You don't want this first column. So you want del D of inside that you write quote unquote A in the square bracket always. So the D is now this. So this column is gone. So, but it is a dangerous thing. So you see, this data frame was capital D, and since you did that, its original table is gone. Now the D, capital D was this. Now the capital D is this. So now you deleted the one column permanently. So it is a good practice that if you have a good table and you want to manipulate, but maybe by mistake you have done that, or you want to have the reference with the earlier one, previous original table. So you always better is to copy. So you write D equal to another, copy this data frame. So in some other name. So you can, I'll show you that. You can always copy that on the interpreter. I'll show you. So it's a good practice that you basically copy before you move on. In some cases, it doesn't destroy the original data frame or whatever, array or something in some actions, but for other actions it does. So you have to always check before doing any big work. So that's why I always tell people that you better write something on interpreter and check for small prototype pilot project to do first, and then you apply this for big project. Okay, so this location and slicing. Well, this location is a lock. There is a lock function. So inside that you write d.lock. So lock is now attribute to D. So you don't write as a function symbol, first bracket. You write square bracket, because D is an attribute to D. It's no longer acting as a function. So anyway, you write inside that B this. That means it is actually, you see, a small b, small c. It is actually B, small b. See, location is B. So B is corresponding is location is 620, right? What it is showing? Oh, it's 620. Oh, so original was this. Original B was this 8620. So I'm again working on the original data frame. So it will show you 8620, right? D corresponding to small b. So D dot location inside the square bracket you write B inverted comma. It will show you, but in this way. Now the you see the columns are coming in this way, A, B, C. So you can save it, and you can see it is probably a series again. See, the structure shows me, since it has no other index in the other direction, you can check it on your interpreter. Check it whether this object d.lock, what is the result, whether this is still a data frame or a series. Okay, I guess this is a series. You can type and you can show. Yeah, d dot this ilock. Ilock is another attribute. Ilock means index location. So instead of the name, I do not know the name of the rows, for example. Maybe I have forgotten. I wanted to see what was there in the second row or first row or something. So I give 1, basically second row, 0, 1. So it will show you the same thing. Instead of the name B, I write 1, and it show you the same item 8620. And of course, it will name and also it will tell you the name. It is a solver. It will tell you the name of the row B, and the data type integer 64. Okay, and the slicing is again the same thing. D1 is to 1:3. That means the rows. It will talk of the rows first, because I'm not talking about the columns. It will talk about the rows. So 1th row and 2th row. It will discard the 0th row and discard the 3rd row. I mean the 3rd row. Okay. So if I now say D1:3 and in that A, that means out of this object, what is under A? Of course, it will show you this sliced portion. So it's a slicing. So this portion. So of course, it is again a series. You see, the this index is not there. One kind of index is particularly row index, that is series. Two kinds of index is make you data frame, and it is showing the name of the column and data type. Well, append and delete, just like yesterday. First, we create a data frame, pd.dataframe, -1, 0, -2. Index is E, and the columns A, B, C. And you see the data frame is a very silly data frame. We have the 1 row and 3 columns, A, B, C, because the columns we have mentioned, columns equal to A, B, C. Instead of putting into like a dictionary, I have separately put index and columns that we began with. So this is one data frame, right? Now you have another data frame, D dot. Okay, so this is the data frame we have created, and we had the data frame D that earlier we had, and let me see again. Yeah, this is the original data frame. A, B, C, D, 4 rows. And now I am adding this data frame with the previous data frame. Okay, so we understand it is going to add with the row. So I write use this append method. So it is now an attribute d.append. Inside that I put D1. Inside that I put D1. So you see, when I write it as a function, we'll use the, and inside this D1 is an argument. When I write as an attribute, we will put as a square bracket. So now this data frame D1 I put inside along with D. So I append this data frame. So you see, this was the previous data frame, and the last row we have now added. So you can, the same concept, no? You know, the when we appended one list with another list, we appended one array with another array. We can append one series, another series. We can append one data frame with another data frame, and so on. The concept is exactly the same. So we have to always take care of the numbers, the item numbers, since it is 3 members here. If we would put here, say, 4 members, then you would see what it happens. Row, you could have many more rows, and then you write d.append. Inside that you write d1, this new one, and you get this extra new row. This way you can make the 2 data frames. You can append the 2 data frames. You can also drop. Drop is another method with which you can drop a particular row. You got a table, you did not like one particular row, and you could you can always drop it. Delete the indexed row. Re-indexing. This is not very. It is forget that. This is not very interesting. So this is end of Pandas 2. I think this is these 2 things in data structures in Pandas they are important series and data frame. But for the sake of completeness, I just will show you about the panel data, which is now dropped from new Python 3. But for a completeness, I can tell you because it was in Python 2. Anybody using Python 2 you can use that.
স্যার বলছি যে ডেটা রোটা আপনি ডিলিট করলেন ওটাকে আর ব্যাক করাবার কোনো পদ্ধতি নেই এই সফটওয়্যারে?
হ্যাঁ, ব্যাক করানোর পদ্ধতি আছে আমার মনে হচ্ছে এখানে দেখে। আমি এটা ইন্ডেক্সে বলছি না, আমি করে দেখি। দাঁড়ান আমি করে দেখি। এখানে করে দেখলেই হয়। হ্যাঁ, আচ্ছা আমরা কি করেছিলাম, আমি এখানটা করতে পারবো না, আমরা এটাকে ছোট করে দিই। আমরা কি করেছিলাম দেখি।
এই কলামটাকে আপনি ডিলিট করে দিয়েছিলেন।
হ্যাঁ, ব্যাস আমরা বানিয়ে ফেলি একটা ডেটা, রাইট? আমরা এক্ষুনি করে দেখি। দ্যাটস বেস্ট আইডিয়া, সবচেয়ে করে দেখাটাই ভালো। You can okay, no, it is not here. Yeah. Let me open these things first. Oh no, I can use this Python 2. I have 2, 3. Let me see if it is there. Whether is it? You can see it, no? Import pandas svd. Oh, it's not here. In this, I have not. I will use pandas Python 2. Okay. Let me check first. Okay. Okay. So here I can. It is Python 2. I have both Python 2 and 3. But in my Python 3, I have not yet installed Pandas. So for quick reference, I can show you. Okay, import Pandas svd. It will, for the first time, it will take little time because it is so heavy. And what we are doing? We are doing here. Yeah. Let me check what I was doing. Oh, it is taking so much time. I just copy it from here, so that's why it will be easier. It will be easier. So I'll do this. Well, so first I copy here. So I first copy here index, and then I make a series. Okay, and make another series. Make another series S2. Then I create the data exactly the way I showed. I'm just copying this just for the sake of this thing. And of course, this is the data frame. This is the data frame. Okay, so you can see this data frame is here. Okay, and now what we did, we also included this. Okay, I do everything. Here I paste. So now see this ABCD. So what I did is a d dot drop, right? I wrote here. Here. Let me see. So d is here. So d dot drop is a function. So I write colon. I'm the inverted comma a. So now this. Now see, I have not told you that whether d is changed or not. This is very crucial to know. You have asked a very crucial question. Now the result of d dot drop is this. It is showing this. Now see, check whether original D is gone or not. Capital D is, no, it is not gone. Okay. So, madam, this is the answer to your question. So, when they have designed this, they have actually thought about that we can accidentally drop one row and then পরে আমাদের মাথায় হাত হয়ে যাবে কি হলো আমি মুছে ফেললাম কেন
সেটাই স্যার, তখন যদি ডেটাটা দরকার হয় কি করব,
দরকার হবে না, সেজন্য দেখুন যে অরিজিনাল ডেটা ফ্রেমটা কিন্তু ঠিক রয়েছে। তার মানে আমি যদি এইটুকু অংশ আমি ধরুন আমি ডি ডট ড্রপ মানে এইটুকু হলো, কিন্তু এটা আবার যখন ডি করলাম তখন এটা রয়েছে, বাট হাউ ডু আই get this truncated portion? I mean, I don't want this whole thing. I don't want this whole thing. I mean, this whole thing I don't require. I actually get rid of this part. Okay, but I wrote this is this, but the original is not changed. So what I'll do is that I will actually copy that. So d dot drop a, I'll copy another, say I take it, say r, I naam dilam r mone kora jak. So now is this. Now your R is this. So you have a new now a new data frame R, where you have the truncated versions. Okay, so that is the thing. So okay.
ঠিক আছে।
Okay. So this ends the basic introduction of Pandas. There are of course many more in Pandas, but for the time being and for our simple purpose, I think this will do, because now the later you can explore. Suppose you have since we have opened this basically this okay, since we have opened this interpreter, we can now okay, let me little bit reduce it, otherwise it is too big to, okay, apply. Okay, now I can I can check the directory pd. So it is lots of things are there. See, so many functions. These are these built-in strings, then these classes and the functions. All these things are there. Okay, so later we'll see. We'll use this read.csv. This function we'll use. So you can understand this read.excel. That means it can read Excel sheet. Okay, etc. We'll use later. Just now we'll do that when we'll show the example, real example. Okay, it can actually read a table, and also all kinds of things are there. So it is all there. Okay, so also it is if you want to see what is a data frame inside, so you can write help pd dot dataframe. So you can see the help. So it will be obviously a very big thing. Lots of things are there. So data frame is a huge thing, huge manual. It goes. You lots of things will be there. Lots of things will be there. So you can actually read all those. These examples are very nice. They have given, unlike other computer languages where computer scientists basically write in their own terms, jargons. So it is difficult for us to understand their language. But Python is written for people where anyone can use, everyone can use. So it is written in a very understandable way. See, it has shown the how you write data, then index, and columns, etc. That I was telling you. So you don't have to follow any other lecture or any manual. You just follow this manual. This is enough. So you just have to know what package you have to know, and what are the kinds of functions and methods closely, approximately you can have to use. That you will check with your help or directory these functions, and can see it's a huge thing. I mean, it's just on data frame, the documentation, you see this, so much of effort they have made. Lots of things. These are all documented, all full of things. And even here it starts from here, so you can check yourself. Similarly, there is a manual for pd.series. and so on. I just for the sake of completeness, I'll just a little bit introduce about pandas, so that you can get the feeling how they actually structure the data. So I just only will tell you, and then but I can tell you the panel in pandas, but you won't use that now. But suppose sometimes you can just can have where is this? Well, this is the last video where I can. This is the last part. Okay, slideshow, beginning. Okay, so this is the last part, Pandas part 3, where actually I told you that the data structures are series, data frame, and panel. And oh, yeah, it is important. In this, I forgot. I have actually here showed you something, big data as data frame. Of course, I will show you with the original data, but here I can just tell you how you do. Oh, this is, I will tell you actually, but I introduce you. Anyway, suppose you have a data source, right? Somewhere you get from internet, you get a some data source and go to some site here, and you therefrom you see some raw data, you download the data, some file will come, and the files are basically CSV files. I told you yesterday CSV is comma separated value, so or TSV, tab separated value. Now they are called CSV, and you suppose this is your Excel sheet. This is basically Excel sheet, but when you save it, when you give it to people, you come to file, come to file, and you click it and you save the file in the CSV format. Okay, so it's the original data. I'll just show you in the an Anaconda. Okay, but this I prepared the demonstration for other purpose. Anyway, so you have this Excel sheet. And you write this. Okay, this is it. You just saw it. No? Read underscore CSV. This function I will use here. Okay. Also, I could use this. Suppose you read Excel sheet and make it to convert it to data frame, and then to NumPy arrays. You could do also otherwise. You could make a data frame and then convert it to Excel sheet. Also, you can do from here, Python. So Python is capable of doing everything. So I'm not showing this. Okay, this what I will use is that pd dot is simple. pd dot read underscore CSV. This is the function name, and inside that you write the entire path name with the path name, and the file name is this. File name is very big. Time underscore series underscore 2019 hyphen encom hyphen confirm.csv. So you do that and you see type. This is a data frame. Of course, I will show it again. And now if you write df, so the whole thing, if you read with this read CSV, and this automatically becomes a data frame. So when you check that, df dot head this, it will show the head of this. You see the okay. You see the Excel sheet. Head means some 1, 2, 3, 4, 5 up to 5 rows. Initial portion it will show you. So this is it will show. Of course, dot dot dot. There is lots of columns are there. So it shows that 5 rows and 66 columns here. It shows only 5 rows, and the columns, all columns. So this is that. Okay. I'll come here. I'm not going to tell it just now, but I wanted to talk about panel. Just a little bit about panel. So you have seen there are 3 kinds of data structures: series, and then the data frame, and then panel. Actually, the name pandas comes from this panel. Panel data. Basically, the idea is the series is one-dimensional data, data frame is two-dimensional, and panel is three-dimensional. So they call it container. So panel is three-dimensional means panel is a box, it's a container. Inside that you have the sheets of data. That means data frame. And then inside the data, two-dimensional data sheets, there are lines. So these are series. So basically this idea. So panel is a 3D container, data frame is a 2D container, and series is 1D. Okay. So and I wrote here the panel is not there in Python 3 version. Okay, but still I show you what it does. Suppose you have a data, and you know the data is two-dimensional data. I have created through random number generator. So you have a data, not a two-dimensional, it's three-dimensional data. Because you know, for a series, you have to feed the data one-dimensional. For a data frame, you have to feed data in the form of two-dimensional data, either a 2D array or a dictionary. Dictionary, basically, it will create a two-dimensional data. So for the panel, of course, you have to feed three-dimensional data. See, 1, 2, 3, 3 square brackets, and here also 1, 2, 3, 3 square brackets. That means it's a three-dimensional data. Means how do you know? Basically, this one is a matrix, two-dimensional, and the collection of two matrices. This is another matrix. So collection of two matrices. So data is three-dimensional. So if you write p equal to, pt dot panel, inside that you feed this data, 3D data, and you try to see how it looks. Of course, you can imagine it cannot show you because it can show you only 2D data. 3D data, how can it show you? Because the other axis, beyond tabular form, you cannot actually in this, you cannot just plot a, it's very difficult to represent a three-dimensional data unless you is with a very peculiar thing, with a rotating box you show. Otherwise, you can always whenever if you see a box on the screen, the data if you want to see, you can always see one face. So that is a special thing. If you even want to see a box, all the faces of the box, the face one by one face of the box. So you have to rotate that, but that's very difficult thing. So what I tell you is that the pandas, if you write p, type p or print p, it won't show you the data structure that way. It will give you the information about the access. You see the it has written class pandas.core.panel.panel. So basically it's a panel. Okay, and the dimensions. So this data is 2 by 3 by 4, right? So two matrices, and each matrix is 3 rows, 1, 2, 3, and 1, 2, 3, 4 columns. So basically 2 items, it has written 3 major axes and 4 minor axes. So that is the information it is giving. And the item index is 0 to 1. This is one item. Now this is a kind of row. So whole thing is 0, and the whole thing is one item. So this is 0 item. This is one item, and the major axis 0 to 2, 0, 1, 2. That means major axis means rows. These rows are now 0 to 2, 0, 1, 2 automatically. This is 0th row, 1th row, 2th row, and the minor axis is these columns. See, 0, 1, 2, 3. So that is 0, 1, 2. Basically, it will be basically 0, 1, 2. 0, 1, 2, 3. Right. Okay. So this is the information it will give you. So suppose in some case in hierarchical structure, you want to keep your data in a three-dimensional in a box form beyond table. We cannot actually, in whole our lifetime, we cannot think about any data stored in a beyond a tabular form. We always know that data is table is enough. But in some reason, suppose you want to store it in a box form, then it won't show you, but it will show you what is there in what axis. This is as if kind of shuchipotro moto dekhiye dilo arki. So I will go here. I just want to show you here. You can create these. Let me see. I won't show you here quickly. I will show you. Yeah. So if you only write if you only write p dot values, okay, then only, suppose I created this data frame, this panel. So I created this panel with the help of a dictionary of data frame. See, this is a key A, and the value is not a series, value is a data frame. Earlier you created data frame with the dictionary of series. Now you create panel with the dictionary of data frame. So see this key is A, pd dot data frame. Inside that you create some with random number, and then another B column. What we thought of columns now. Now we will see what is A and B, and these pd dot data frame and these things, and comma index and comma index. Okay, so the panel is created and panel is showing you like this. See the items axis A to B. That means two matrices, one matrix A, another matrix B. Major axis means rows A to C, ABC. The minor axis is 0 to 0, 1, 2, 3. That means columns. Okay, so it will show you that way. But if you want to see the p dot values, then only it will show you. So this is the original data. That means p dot values means data. But now this whole thing is A item. This is B item. This is 0, 1, 2, 3 columns, and this is A, B, C. That's it. Okay. So we end our discussion on panel here, pandas here, and we'll begin to show you a real data, COVID data, what we did. Okay. Okay. কিছু প্রশ্ন থাকলে করতে পারেন এই মুহূর্তে, তারপরে আমরা ওই রিয়েল ডেটা অ্যানালিসিস চলে যাব। You can ask questions please if you have, and then we'll go to show you, because আজকে আর বেশি দূর টানবো না, কারণ এক্ষুনি শেষ হয়ে যাবে, মানে আর বেশি সুতরাং we'll have a lot of time to talk if you want. Okay, can I begin to show, or you will ask question?
কোনো কোশ্চেন করবেন?
কেউ করবেন না, করলে করতে পারেন, otherwise we can move on.
আচ্ছা, কেউ কোনো কোশ্চেন করবে না?
ওকে, আচ্ছা, প্রশ্ন করবেন না, তার মানে কার পছন্দ হচ্ছে না আর কি। ওকে, আচ্ছা, ওকে, okay. See, you can see the letters, right? These are very small. I think you can, if you're on your laptop, I think you can see that. Okay, so this is, again, we come back to Jupyter notebook that we were doing. So I actually saved my time for typing. So I typed everything here just to save time. So here I checked this data, COVID-19 data, all the cases, confirmed cases, recovery cases, and the dates, the three kinds of data. And when I did this data, I analyzed until 23rd March. Now, if you now do it, you can see data up to yesterday or yesterday night. So these are the old data, of course, but it's for demonstration. You can now check your own data. I mean, you can now do it after this demonstration. You can do it yourself, and you can now do it with your current data. What is the world situation of COVID-19 virus, COVID-19 disease? Okay, so I search it myself. There are lots of data sources, and some data sources can be controversial, or some are not very authentic, or maybe authentic. I don't know. I don't care also, because it is for demonstration. So I thought this data source is very I can depend on. Okay, authentic. So this is, I can show you how it is there. So I copy this site, go it here, and I can paste it, and you can see if my net is good. Okay, I think, yeah. So this is novel coronavirus COVID-19 cases data, and you can go to this site and you can see this logo. This is the Johns Hopkins University, America. So this is basically maintained by University Center for Systems Science and Engineering of Johns Hopkins University. So they maintain the data, and you can go to here more. So the earlier data series were the 3 files were here, time series, but now they have actually discarded it. They have disallowed. They are disallowing you to download data from here. So data were here, here, here. These 3 files you see, the time series underscore COVID-19 underscore confirmed underscore global dot csv1 was there. This data was there. Also here was the data time series. Source of all kinds of computer software, all the free. So GitHub is a kind of bazaar where you get all kinds of data, all kinds of things. So this is very important site itself, GitHub. Okay, so this is very important. So now you can see the data here, all this. So you can actually download all this data. Visual wordboard, dashboard, and etc., 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 etc. All this you can see this. Not only COVID virus. If you want to do a research on some other disease, pandemic, or some other kind of epidemic, you can Ebola. You have Ebola data. You have all other pneumonia data. You have all kinds of data there. Lots of data. So you can basically, these are all raw files you can have. There are actually 2 types. In many places you will see raw files, and if you have the raw files, your life is easy. Otherwise, many sources, they don't give you the raw files. They will display this, and they will display the table, everything, and there is a lot of effort you have to make. The convert their table into our table, into our raw data, into our data frame. Otherwise, you cannot deal with the data. I cannot just copy the picture of their table and can use, and it is useless to copy by hand. So basically, but we have mechanisms. We have all the mechanisms for everything. So first I show the easier part. So you go any of these things, and archive data also you can go there and check what are their data. Lots of now they have changed the forms of the data. I mean, they change the forms of the files and everything. They do it. They were doing it for daily basis. Anyway, so it was the source of the data. Okay, good. So what I did is that I went to this site, I clicked, and I downloaded the data files. Okay, so the data files were here, and this is in this machine, particular machine. This is I give the full path name, users, then users name, then desktop. I created one directory AKG, then the file name was time underscore series underscore 2019, etc., etc., etc. Yes. Let's see there what the data is there here. Otherwise, it won't work. Time series. Yeah. See, one of the this is the time series. It's the Excel sheet you can see. Let me see. Yeah, so this is the data file. This is the data file. This is the original data file. They what they did. Okay, so you see the name of these are the first in these indices, right? These are the row indices 1, 2, 3, 4, 5, etc., etc. In fact, in the data frame, this is also can be thought as this headline. That is where the columns are there. It also can be thought of as 0th row, but doesn't matter. We know how to, when it is data frame, how we can tackle. So this is the first column, province and things like that. Then the country, then the latitude, then the longitude, and then the dates. And the dates comes from 22/1. You see, 22/1 means January 22. And this is this, and you see this goes up to the end of, this is the 24th. Here I reloaded. So 24th week up to 24th March. Okay, and so it is this. And you also notice from the frame from this table, you will see later. It's a huge data file. Basically it's a big data. It's a huge data, and you see there are lots of rows up to 242 or something. And in some columns, you see these columns. This row, in this column, some rows are empty. So you know when Python will read this, it will show you nan, nan. And also in this row somewhere some data will be missing. There will be no data. So in that case, it will show you nan, means not a number. Okay, so that you know now. Okay, so now I delete it. Okay, now okay, click. Yeah. So what you do first, you have to import NumPy as NP. NumPy is important for you. Import Pandas as PD. This is very, very important. And also to plot, I will plot the data. I wanted to just only do that. No modeling. So import matplotlib.pyplot as PLT. So the you need the three packages: NumPy, Pandas, and matplotlib. Well, so let me run it. Let me run it. Okay, I think it has taken. It is not saying anything. It's taken. Now see with the read CSV file, read CSV function, read underscore CSV, that is there in Pandas. You saw it. So it is under PD. So you write PD dot read CSV, and inside that as argument you just give the full path name with the within inverted comma, full path name and the file name. Until this portion is path name, and after this is the file name. So you save the this thing into a name, that is I call it data underscore confirm, because it is the confirm cases. Similarly, I downloaded another file which talks about recovered cases. I rename it data underscore recover. Then I read another file which is deaths, about deaths. Okay, and then I write data underscore death. In fact, these three data are important in a sense. You have heard about, or some of you may have worked on SAR model, SIR, right? SAR is susceptible, infected, and recovered. So these data are important. These three forms of data are important for this particular model, and all the people's prediction, graph, etc., modeling, all these things people are doing is based on the SIR model. SAR model is the model for analyzing this data and for pandemic or epidemic spread and everything. So lots of mathematicians, physicists, computer scientists, they love this model. They manipulate the model, they do something this and that, and make paper every week. Okay, so they do that. Well, by now with this data, you may have seen lots of thousands of papers in the archive. Okay, anyway, most of them are useless, of course. So now you see what are they? Data underscore confirm, data underscore recover, and data underscore death. I just want to check one thing. So I just have to run first. So it has read. Since here the number has come, means it has read successfully. Now I want to see, first thing is to I don't know what is this kind of file. So since I read with read CSV, I just check what is data confirm, one thing, and type it. Aha. So this is data frame. So your job is easy. Now you know what is data frame and how you can tackle data frame. So this is a data frame, no problem. So this is elementary. Now you know. Okay. Now you know. Now you want to see this thing. The head of first you see what is the head. That means whether the data came correctly or so. Okay. So see, this is data frame. So this is the Excel sheet. The up to 50. Up to 0, 1, 2, 3, 4, 5 rows. See, I told you these provinces, these names these positions were vacant. And so Python has, I think, not Python means my PD, by Pandas here. It has automatically assumed this is NaN, in NaN. So the provinces, see, for the country Thailand, there is no province. For the Japan, there is no province. They have not included data here. And it shows the latitude, longitude, and the data from.
একটা কথা জিজ্ঞেস করা যাবে স্যার?
হ্যাঁ, sure. একটা কেন, just
বলছি স্যার একটু উপর দিকে একটু উঠাবেন স্যার, ওই লাস্ট আপনি জাস্ট কিছুক্ষণ আগে যেটা 3টে ইম্পোর্ট করা হলো না?
হ্যাঁ, এটাই।
ইম্পোর্ট, হ্যাঁ স্যার, ওই ইম্পোর্ট করার পর ওই জায়গাটা ইম্পোর্ট করে ওটা যে ডেটা ফ্রেমে তৈরি হলো, এই কনস্ট্রাকশনটা আরেকটা বার একটু স্যার বললে ভালো।
ডেটা ফ্রেমটা ওটা অটোমেটিক্যালি তৈরি হয়ে গেল।
হ্যাঁ, অটোমেটিক্যালি তৈরি হয়ে গেল।
হ্যাঁ, মানে কেসটা হলো, আমি যদি read underscore csv এই ফাংশন দিয়ে দেখি, ও অটোমেটিক্যালি আমাকে কিছু ভাবতেই হবে না, ও এক্সেল শিটটাকে নিয়ে বাংলা একদম ডেটা ফ্রেম বানিয়ে দেবে।
মানে তাহলে স্যার এখানে তিনখানা ডেটা ফ্রেম তৈরি হয়েছে না একটাই ডেটা ফ্রেম? তিনটে ডেটা ফ্রেম তৈরি হয়েছে।
আমি একটা দেখাচ্ছি এক্সাম্পল হিসেবে।
হ্যাঁ, ওটা একটা এক্সাম্পল হিসেবে।
হ্যাঁ, মানে এই যে কপি, সব কপি পেস্ট।
ঠিক আছে স্যার, ওটা জাস্ট মানে ফলো করতে বললাম না, যে কোনো কিছু। ঠিক
আছে তো?
ওকে স্যার, ওকে।
হ্যাঁ, ওকে। So I'm just seeing this. আমি যদি এটা দেখি যে এটা কি আছে, আচ্ছা আমি দেখে নিচ্ছি কি আছে, দেখতে কতক্ষণ লাগে। হ্যাঁ, আমি দেখুন, so what I want, আচ্ছা 8% of that I just want to discard it. Yeah, I want to remove this also. I want to remove this also. I don't know. After this, okay, I check the one kind of thing. What is this? And then I want to check step by step. I check what is there inside. So how with the data frame, the first few lines, what it shows. It shows these 5 rows and 66 columns, and the data you can dot. That means it has not it's not showing you everything because it is so huge. Here in this up to 23.3. Okay, fine. 23rd March of the data now. And you can, if you write head under this, if you write say 50, that means it will show you 50 lines, 50 rows. You run and it will show you the 50 lines, but you don't want to see everything. See, in some places, see in this column, see I told you the first column, province column, some places were missing. There was a blank, it kept blank there. Whoever have copied data in the Excel sheet, they didn't put anything there. No number, nothing. So it is, Python is taking them as NaN. Then for the Canada, the one province is British Columbia. For that data is there. For Australia, New South Wales data is there, etc. For Australia, you see there are several provinces. All these provinces are there. And Cambodia, Sri Lanka, etc. The way they did. Here India comes. See, in the 15th position, 15th row. Okay. So in India also they have not talked about any province. So it is NaN. Okay, so this is you can see 50 data points, you can see 10 data points, say so whatever the way you like. Also you can see the tails. Also you can see the tail. So you can I can take it up. You can copy this. You can copy this. You can copy this, and you can see the tail also. Tail. এই জন্যই এই আনাকোন্ডাতে পাইথন জুপিটার নোটবুকে কাজ করার সুবিধা হচ্ছে, things remain here and I can always copy and manipulate. So that's why it's for data, big data analysis. I think people always prefer this Anaconda platform and Jupyter notebook. So if you write tail, last 5, so it will show you the tail. See the last 500, it is about the total rows is 500, right? So it shows you the up to 500. So basically, so it shows you the tail. Also, if you want to see, as you were saying, that I can also see this. What is recovery? What is the data for recovery? It's another data set. So I can create one shell. I can write this and dot head data underscore recof head. Sorry, I can also see that. I can also see that. So it's a recovery. So of course you will see the all these columns will be the same, but it's this data will be for recovery rate, not rate, recovery. How many people have recovered? This is how many people have confirmed COVID, confirmed corona attack, positive case. And then another file is there for death, how many deaths happened. So these are the things. So now you can see that the data is at your hand. Means you know data frame, so you can now apply all the methods. Now we can think of a model. Now we can plot everything. So I show you some demonstration furthermore. Okay, so there is in the my data frame is data underscore confirm, data underscore recof, data underscore death. Right? These are my these data underscore recof. So these are my these are the names of my data my data frames. Now in this inside you go there, and you see there are, I can also see the values of data frames. I did show you values of the data frames, so it will show you the values. In my presentation I did show you the values for data frame. I showed you the values for the panel only, right? So if you write data underscore confirm is the name dot values dot, so there is a method called toList. That means what it does, toList is a function. So that it does, it will create from data frame to a list. Suppose I want to handle a list better. I know how to handle a list better. So I can do that. Also, you can have, I have hashed it. I'm not using at the moment now. You could also write data underscore confirm to NumPy. Up to this you could write. So data underscore confirm dot to NumPy. Let me check once. Here. Yeah. So write say data underscore confirm. This is a data frame, and I can write dot. First I write two values. Let's see what it shows. Two values. So it only shows the values, but not in structured form. Only the values. Okay, and it is automatically a NumPy array. So I can type it to see what is the type of this. So the values gives automatically in NumPy arrays. So it's NumPy array. Good. Also you can see it. Also you can see it as data underscore confirm, and you can also directly convert it to NumPy. If you also can use that to underscore NumPy. Also you can see that. So it's a NumPy. So it's all the same thing. If you use data underscore dot values, or if you use data underscore data underscore confirm dot to NumPy. Also you could write from NumPy array to, you can also convert it to list, ordinary list. So that way we want, you can write this as to list, and you do that. If you do that, then it will be a list. So it will be, now it is showing. So it's showing is a long list, two-dimensional list, of course. It is showing this way. Only NumPy array shows this way. Okay. So this is something, anything you can do. Okay. So suppose I did it in this. I don't know why I wrote this, but it is automatically you could do this. I converted these values into toList. It's not necessary, but I did it here. Okay, let's see. Suppose I do this data underscore confirm dot values. That means up to this is NumPy arrays, and then you convert it to list. And this I rename as L underscore confirm. Similarly, L underscore recof, L underscore depth. And see if we write this, yeah. Oh, What is this? Yeah, it is. See this? This. Yeah. It is a list. It is the same thing. So it is showing you the list 2D list. Okay. That's it. You can whatever you can do. Okay. Now I can check in this data frame data underscore confirm. Now see, I can use this loc location method. Where is my country India figures? I could see it here. Okay, of course I could see it here that India is at the 15th row. So I want to analyze data about India. So I go here, and this if your data size is huge, you cannot see it. So I can write data underscore confirm dot loc. Under that I write that data underscore confirm. Inside this square bracket, I write country in this column, right? In this column, you see this column is country region. India will come in this column, right? So I write exactly that. I write exactly that country public region, quote unquote. Of course, you have to give, and you have to write equal to. That means when that equal to, when this portion equal to will be equal to India. So this string, when this thing will be equal to India. So now see, it will show me the position. It will show me the data, that particular data. Run. See, only this portion. See, this is 15, province state Nan, country region India, latitude, longitude. That means it is probably of Delhi's latitude, longitude, and the data. And you see, for India, there was no data for January. You see the all 0, 0, 0, 0, 0. But India case started, story started February, in February, say. So in January, there was no data. When China was at the peak, Italy was at the peak. Okay, so now I know. So first I wanted to see the cases of India. I wanted to compare with India's, at that time, India's confirmed recovered death case with Italy, Spain, UK. I wanted to compare with all European countries. Okay, 3 European countries and India. I wanted to plot all of them together. Okay, so what I did is that same thing for everyone. So I wrote L confirm, and this I wanted to have 15th position. See the L is this, L confirm is this, right? L confirm is here. This is the list, L confirm, right? And here is this, here is this. So this is the first, this is the, I mean, this Thailand is the one first, 0th, up to this. Then Japan, this is 0, then Japan up 1. See, another list comes. So this is list under list, right? You know, this 2D list, like an 2D NumPy array. So I'm thinking about the first item in the list. So that is for Thailand. Second item for Japan. So in this way, 15th item is 15th position item is India. I know the 15th position item is India. So in this list, L underscore confirm, I write 15. So I rename it as confirm underscore India. You can write anything. Similarly, L underscore in the other file, recover file, same way, I write L underscore recover 15, that is recover India. L underscore death 15, that is death India. Okay, so this is for India. These 3 data are for India from 3 files. Similarly for Italy, I know Italy is in 16th position. Spain is in 18th position in that list. In this this thing, I can write here Italy, Spain. I could get. So Spain is 18th position, and the UK was in 403 position. I think they didn't put it alphabetically, but okay. Well, some randomly they put it. So these are the 4 sets of data. Each has 3 different things. Okay. So now I run it, because I will use these names. I will use this confirm India, recover India. In this case, names I will use. Now I will plot. Okay. So plt.figure. I want to create a figure size 10,8. That means my figure size will be 10 by 8, width 10, height 8. And you have already learned it from matplotlib that if I want to plot these 4 countries, I want to present the data to people that the 4 countries I want to show you side by side. Okay, fine. Then I have to do the subplot. You just had day before yesterday that the subplot is here. So I divide this space into 4 quadrants, 1, 2, 3, 4. So the first will be India, second will be Italy, third will be Spain, and the fourth will be UK. So you see, one is whatever I do for one, I do fit everything for all the countries. So subplot I write 2 to 1. That means 2 by 2 this arena, and the first position. Then it is 2 by 2 to 2. It is 2 to 3, 2 to 4, and I plot plt dot plot. Okay, now okay. Here also I missed it. Days. So I obviously will not plot this date this way. It's not necessary. Okay, I wanted to do this way. Also, you could plot, but that's some other trick is there. But of course, I want it to be simple. This is I consider this is the 0th day. This is the 1 day, 2 day, 3 day, 4 day, 5 day. So now I counted how many days are there. Of course, how many columns are there. So these are the 66 columns are there, and out of it you have 1, 2, 3, 4. These 4 columns are useless because these 4 columns are not the data. These 4 columns are not the corona data. These are the other parameters: name of the country, latitude, longitude. I don't want to plot them along with them, right? And these are the automatic indices. So you see, out of 66 columns, what is out of 66 columns? Oh, it is why it is stopped. Let me see. Can you see my screen? My screen is stopped automatically. I don't know why.
Yes, Dharaj.
You can see now. Oh,
Yeah.
Maybe I see. My screen is okay. It was reloading because it is so heavy. Let me see. Where did it go? It's gone. It is. Oh, it is redoing. Okay. Anyway. Okay. So since the data are heavy, let me not see everything now. Okay. So this. So see this. Okay. I look at this. So I wanted to see how many days are there. Of course, the days are 66. I know it, but still, by computation, by I know the technique. Confirm India. So the confirm one of the cases. Confirm India or recover India. The lane of this list, right? How many? What is the length of this? If I say what is the length of this 2-dimensional list? That means in the list, 2-dimensional list. This is the up to this whole Thailand ka data. That is one item. This is 0th up to this, right? Up to this. So this is the 0th. This is the 1th, right? This way it will count how many countries are there. That means how many columns are there. So here you can do it in your own way, whatever. So I wanted to see how many number of columns are there. I can see it is 66 columns. It is showing 66. But of course, I was not satisfied. I said, okay, let's see. Confirm India, this data. One data is enough because all data are same. And I think what is that lane? Okay, you can check it. You can check it here. So if you can see lane of confirm India, one set of data. So the lane is 66. Right? I mean the total length is 66. That means 66 columns. And you can always by seeing it, you can see this 1 column, 2 column, 3 column, 4 column, and so 4 columns are unnecessary here for my case, for my plotting. So anyway, and I want to create. If I want to create a range, range of, I can actually write here. I can, if I want to create a range of these, that means 66 range means it will create a list of numbers which will be, which range will be 0 to 66. I can of course print and show you. If you have to believe it, it will be a list. It will be it is a Python 3. So you have to put it inside this, okay. Yeah, I have to put it here. 1 2 3 1 2 3. Oh, one is missing. Still it's not showing. It will show you if you write, say, for it was, because in Python 3 it doesn't show it always. In range, say, if you write here, say, if you write for in range, okay, then colon, and then you print I, then only it will show you one item. Print I. I'm sorry. Print I. It is a function. Print is a function. Okay. Right now, for I in range, what is this happening? For I in range, print in range, invalid. Oh, here. Oh, acha. Oh, one. Okay. Oh. 1 2 1 2. Yes. Now it is going. See, now it is showing that it is the creating numbers between 0 to 65. So that means it will, the range, what it was showing, basically, I won't write everything. So the range of these is basically, it is creating a list of numbers. It is basically, what again? Again, I'm sorry. Yeah. So it is basically creating a range of numbers. That means it is creating a list of numbers between 0 to 66. That means we want to mark this as 0th day, 1st day up to 66. I mean 66 columns. So 0th column, 1st column, 2th column, 3rd column. So if I now discard the first four columns, then this column will be the 0, 1, 2, 3. Oh, this is 0. Actually, this has taken. This index is taken. 0, 1, 2, 3, 4. So the date comes from 5th column. So I actually checked that time, because this index is not automatic. This index they have put it. 1, 2, 3, 4. Not 0, 1, 2, 3, 4. This index, like we were putting the indices. Okay. So anyway, so now you see this is done. Days is some variable where it has the range of days. Well, so when we plot, I was careful to plot. See, days is the list of numbers, but I discarded first 4, 0, 1, 2, 3, but I mean first 5 elements, 0, 1, 2, 3, 4. And from the 5th index, the up to the last. See, this is called slicing, right? You have seen it, that like if you write, say, out of this, see this thing, this is say, if you write, suppose if you write this is okay, if you write it as some, say, x equal to this, and then you write x, say, 5th column, 5th index to the rest. So it should show you the rest of the thing. So it will show you from 5 to 66. It won't explicitly show you in Python 3. Python 2 it shows you. When? Well, so the first 4 columns are actually dropped. I mean, I'm not considering, not dropped, I'm not considering. So basically I plot days 5 colon, and similarly confirm India also 5 colon, and I plot with the hyphen and bullet. And now I decorate the text, plt.text. At this position 4300, I write India, size equal to 18, and then I write plt.x level days, x-axis days, and the size of the x level is 16. And I do the same thing for Italy, same thing for Spain, and same thing for UK. Now see the plot. So here is the plot. So I mean, it is up to you now. What kind of presentation you will make to show people or to write paper or whatever to analyze. So this was the India case. This was the Italy case, Spain case, UK case. Of course, you have to plot together to see which beats what. Okay. So every country has a more or less same thing, but a specific nature depends on their infection rate and everything. So now, if you think that okay, I will do some derivative of the growth. The growth rate, the confirmed rate is growing, is the growth, and I want to see the derivative. So day by day case, what is the difference between tomorrow and today, and day after tomorrow and so on. Okay, so this you did. Again, you do that, and now the derivative that will be one data less, because if you have 4 data, so if you take derivatives, that means 1, 2, 3, 4, 2 minus 1, 1 data, 3 minus 2, and 4 minus 3. So there the data size will be reduced by 1. So now you will plot with days 6 colon onwards. That means one number is reduced, right? And you now on the confirmed case, you write this, and I use this method in NumPy, DIFF. There is a method called diff. Diff is actually differentiation. So it differentiates. That means it takes y2 minus y1 by x2 minus x1, right? So like the differential, it does. Okay. So diff function, without doing it by hand, I use the diff function. I just did it. This np.array. See, here I wrote np.array because actually, for some reason I don't know. I mean, now I converted this as lists. I could put always here. I could. I mean, I could always make it as NumPy array. I could do it always first instance. But why I didn't do, I don't know. I mean, that time I was thinking something else. Anyway, so there is always a remedy. So you can, what you do is that you later I converted this list into NumPy array. You do not have to do that. It's a foolish way of doing. I did. np.array. Inside that I confirm India, this thing, and 5 colon. So this I took differentiation, and so the days will be 1 less, and I did the same thing for everyone. So now I try to run and see. So it is the plot of differentials. These are the real, the original growth, and these are differentials. So the data will be zigzag. So these are haphazard. So some days the confirmed case increase too much, and the another day it is not that much. So, but from the differentiations, you can get a better view. That means whether the rate of increase day by day, that rate is saturating or not. Suppose rate will increase. I mean, the total growth will increase, of course. Today the infection is 100. Tomorrow it will be 120. Another day it will be something 150 or so. But today the difference is tomorrow. And today is 20, and then it will be maybe 130. So the difference will be 10. If the difference decreases, then we understand that confirmed case is increasing, but the day by day the differentiable confirmed rate is decreasing. That means we are saturating towards something. So for that I wanted to plot this. Okay, and later I wanted to plot with say India's. I wanted to plot with a ratio, RECA of India, and since the Indian data I saw that the first 11 days there was no data. First the 11 columns. India's data began from 12 columns, because you see the data here. See the first, if you go and check the whole data sheet, first few days it will be 0. That means no cases still arrived. So I thought this, okay, fine. I will check for India after from 12th column onwards. So recover India 12 colon by np.array confirm India 12 colon, and the data type is float because the data can be in the integer format. To be on the safe side, I declared them as float. You do not have to write because Python 3 takes care of everything. And then I multiplied by 100. So I estimated this thing. Simple. It's a percentage calculation. So number of the percentage of recovery. So the recovery by confirm, basically recovery by confirm, and you multiply by 100. So this is the fraction f underscore recover underscore India. So the fraction of recovery rate in percentage. So similarly, fraction of recovery for Italy. For Italy also I did the same with 12, just to compare with India. And for Spain also you did the same. For UK also you did the same. Also in the same graph, probably will see fraction of death rate in India. So the death India by confirm India. I just converted this NumPy array and discarded first 11 columns. That's it. And declared the data type float and multiplied by 100. That we do the same thing for everything. So these are the things. Okay. And forget that what it says, because some data it is because objection, because in somewhere some data is 0, maybe it's divided by 0, so it is not able to do anything, but is clever enough, it will do. See the F recovery Italy, if you want to see what it is. So this is this thing. So it's a NumPy array, 1D NumPy array, no worry. And you see here it was because of this I wanted to check. Italy was giving the problem because because you let me see if you are okay, it is again still my this thing is again still, let me see, check. Okay. So it is saying no. So runtime warning, invalid value encountered in true divide, etc. It was showing. It is hanged. Please wait. Okay, it's hanged. So it was telling me that. So encountered in true divide, etc. So I suspected that in the division somewhere there was a 0. I think for the Italy case, it was some confirmed case was 0 or something somewhere, whatever. So I see the recovery rate somewhere 0. Oh, not for this. There one data was NaN. For one day there was no data. Because of this, I can identify. I just checked. Because of this NaN, it was showing that warning. Okay, now I plot again. So now, the calculations we have done here. The calculations we have done here for the fractional cases, and now I plot. In the subplot itself, 2 to 1 for India, and we plot f underscore death underscore India corresponding with the days, and the f underscore recovery India corresponding to days, and the days are from 12th onwards. I mean the column 12 onwards. We write the text, fix the limit of x-axis, we can write the legend, date and recovery, and we put the label x-axis, and we do the same thing for the Italy, Spain, and UK. Okay, so now I run. Let's see what it is. It is showing. Yeah. So this is the graph. Say I wanted to see. So the death rate is much less, of course. So this was the initial thing. India was, so it was recovery. So percentage of recovery. Initial it was 100, showing 100% because there was no the data was not there. So it takes certain 15 days to recover actually. So this is the recovery rate for India. This is the death rate for India. So Italy was danger. Italy was in deep trouble. You see from the curve, the naked eye, you can see this. For Italy, the death curve was so high, it was rising, and it's comparing with the recovery. So recovery was not able to, compete with the death. So Italy was in deep trouble. But for this, and Spain also was, if I would see in this particular truncated portion, we could see. And in UK, it was even more, sometimes it was even more dangerous. After some time, the percentage death rate actually crossed the percentage recovery rate of UK. So UK was also at a certain time was in deep trouble. So from the graphical analysis, you could say a lot of things. Of course, it is nothing. Now the most interesting case is China. Of course, China is controversial, but we won't go into the detail. But the China's data is something. One way you can think something, and the other way you can see it is something to learn from that data. Yes, I'll see China case. So I data underscore confirm, and I checked country region where China figures equal to China, like the way I checked India, Italy, and things like that, right? Like here, see, I checked where India figures in the data frame. So I did the same thing for China. Let's see China, yes, because China was the epicenter of everything. So I considered that data underscore confirm dot loc, and inside that I write data underscore confirm. Inside that square bracket I write country slash region equal to China. Let's see what it shows. Aha! So these people in the John Hopkins people, they have got China's case of so many provinces. You see, I have counted. You can also check with your Python machinery how many rows are here, but you can easily count it. This is 50 provinces. I think China has 50 provinces itself. So it's China's 50 out of 50 provinces. You know, the topmost is the Hubei, and Hubei is the province where the epicenter happened, where the Wuhan city is there. Okay, this is a huge city. One friend of mine here stays next to ours. He spent several months there for business purpose. He went there, and he showed me photos and things like that. He's told us Hubei is this very prosperous city, very huge city. It's one of the on that northern region probably. It is one of the most busiest cities. Anyway, so Hubei was the epicenter of this pandemic. So you see Hubei, Guangdong, Henan, and all those provinces, and the last comes the Tibet. Okay, and this. So I was interested in China, and so for China, since I got the provinces of all the provinces, and so I have data for all the provinces. And there was a rumor in the market, and there was a conspiracy theory that people are saying, why then only we see one? What about the other countries? Why not in Beijing? Why not in here and there and there? But truly, if you are a data scientist, you see the data with your eye. The data, whether data is good or bad, whether the data you can trust or not, that's a different thing. But we are scientists. We'll have data. We'll tell you something from the data, whatever is there. Okay. So here you see that you can at least tell that, okay, I have seen all the data here, all the provinces. Okay, good. So now I want to plot all this data. So 50 provinces, right? So what I did first is that, plt.figure, fixed size equal to 12.8, and since the code, the province names comes from 154 a row to 189. So these, sorry, not 189, 202 up to Tibet. So Hubei to Tibet. So I can tell you, that yes, 154. How many are there? How many? 54, 40. Okay, Yeah. So I can tell you that you can, like this, you could do that like this. You could, for each province you could write this for subplot, etc., etc. But instead of that, you can write a for loop. So for I in range 154 to 203, that means it will create the arrays, keep the list of 154 to 202. Yes, 202 is the best. And so I in range, I is dummy index 154 to 203. And now we write confirm underscore China, L underscore confirm, that data L underscore confirm, and the ith position means the I is 154. That means first is Hubei. So it takes the Hubei's data. Then the data is this Hubei's data, that means the Wuhan's data. Hubei is Wuhan. Basically, Wuhan is the city of Hubei, capital city of Hubei. So the data is so huge that I wanted to plot in semi-log y. Otherwise, the hell and heaven difference, because the confirmed cases were huge here compared to other places. So of course, I plotted it in with plt.semi-log y. Inside that I wrote days, and I discarded the first 4, 0, 1, 2, 3, 4, first 5 columns. You will see, because longitude, latitude, name, etc., etc. 5, because for India it was from 12th. India it was from 12th, right? But now if for China it is from the beginning. So I do not discard the data. I take from the beginning, January 22, from the 5 colon. And the confirm, so the days and the confirm China 5 colon, and these are the decorations. Line would equal to 3. Then I'll plot the text only for Wuhan or Hubei. I just put the name here. So which is Hubei, you can understand from the graph. And the size is this, not for all the provinces, because there are 50 provinces. It is not good to write all the names. And the plot title, China COVID-19 confirmed cases, size this, X label, and also I control the tick parameters, label size I increased, just to show you. So, okay, now I see, run. Let's see. So this is the curve. You see, the curve is very, very kind of, it can tell you a lot of things. First of all, the data, you see Hubei's data. Even it is in log scale, see the order of magnitude. These data up to 10 to the power 3 scales, that means in 1000. It is up to 1000 maximum. And the Hubei's data up to hundreds of thousands, lakhs in terms of lakhs. So these are about all the other provinces. And out of those, some data of some provinces are erratic. They increase certain way, but of course it depends on the administration, the other things, and the population structure and all those things. But it doesn't matter. But most of the data of other provinces follow the same scheme. This shows you something, that the discipline of the something, I think, from the data. If you can conclude that it began, but of course for every country the data will rise and have to saturate. But when do you saturate? When do you flat the curve? When you begin to bend the curve is important. Well, at least one thing we can confirm here: the Hubei is, or Wuhan is, complete different from the other provinces. Well, now I wanted to get rid of all those erratic data. These provinces, not erratic. This data, I mean, looks clumsy. I wanted to show only some other provinces which follow the same scheme. In terms of the statistical physics, I could tell you that we could scale all those data. I can collapse the data on top of others and could see what common factor is there between all the curves. Okay, and so we could do lots of research about within this data. So okay, I actually by hand picked all these data, these, and the other this, and I actually threw this data. I did not plot here. So here I rewrote this. Only I took the first one, 154, this Hubei, and in the sum from 154 to 58 to 163, then 166 to 69, and this. I plot it, and now, but now I have to plot separately for different for loops for different sets of these things, right? Because I checked it. Okay. Now, yeah. So this is the data. So the provinces which follow the almost the same way, and with the one, I plotted this. It is basically the same graph, but you discarded these provinces, these anomalous kind of things. Of course, you could put in the normal scale, but this data is so huge that it will dominate, and the other data you can't even see. This data will be close towards the x-axis, so you cannot get a trend. So it's up to you how you look at data, how you plot the data. And now percentage recovery case is China. I want to see this. Let me see. Yeah, and yeah. Yeah. So the same thing I did. Recovery China, and also here also I plotted with. I discarded first few data points because first few data points are so low. So that's why I discarded. And the recof China 12 colon onwards, and recof confirm China 12 colon onwards. Basically R by C, that's what I was doing previously for India, Italy, etc. And this is the percentage recovery for China. And the provinces, all these, the same thing. I just copied the same thing here. Only the percentage cases. Okay. So we plotted the days versus P. This is the percentage case, and for different provinces which are regular. So let me see. It will taking time. Actually, this program is nothing. And the same thing I'm repeating. Huh? So then first I did that, and let's see, and then I also did subplot also. I think let's see. Yeah, where it is coming? No, it's not coming, or it's taking time. Oh yeah. Here. Yes. So I did the two sets of plots. First, you see it is not necessary to describe again and again. These are the semilog plots of the original data and the subplot. And this is under subplot 211 actually. I have divided this space into two sectors. So 211, 2 by 1, these things, 211, the whole sets of data, the previous data, I put it in just to compare in under 211 subplot. And now I am calculating this percentage recovery. I'll compare with them. And this is under 212 plot, right? And the whole thing, I mean, it's entire thing, I just plotted. So here is my, let me show you this. So this is the previous data. So it's a percentage confirm, and this is the okay. This percentage confirm and percentage recovery. Okay, confirmed also percentage. I converted to percentage everything. So percentage confirm, and the recovery by confirmed into 100. So percentage recovery. So both are in percentage. So otherwise I cannot compare. So this is the percentage confirmed rate. This saturates, and here this is very interesting. I posted this in Facebook also. I mean, in the initial stage, I did this analysis, and for the sake of curiosity, I mean, sorry to say, but I posted this thing, this nice looking graph in the Facebook, and I got lots of criticisms, not on Python, but people talked about Python China, conspiracy theory, politics, etc., etc. And it was, I was so disappointed that I actually deleted, because I thought people are not that kind of quote unquote educated to understand what is happening here. I mean, I don't think the data is, I mean, I can trust or you can trust. But the thing is that there is much to learn from this. You know, the people who work in mathematics or some statistics or something, this curve is called sigmoidal curve. So I wanted to tell people that why this curve is sigmoidal. So it is, see this, the curvature here, more or less, and then it saturates. I don't know I mean, whether every country will follow this curve, but it is very interesting. And I mean, it is nothing to kind of, you cannot kind of deny that the measure they took, I mean, it was devastating there, but the measure they took, the militarized measure, because China is a totalitarian country, everybody knows. It's not like a democratic country. So to talk about the politics. So of course, that is to another thing, but the measure they took, of course, that is exemplary. That I thought can be understood from this graph, or it can be under many more mathematical nature could also be understood from this curve. Anyway, so this is the curve, and yet you see the Wuhan curve. They tried best, their best. I know I read lots of articles by, you know, the name of Yuval Harari. He is the foremost thinker of the world at this moment. You read his books, The Brief History of Humankind and other 3 books, the 2 books. So he wrote an article, and he told that in China they actually control everything through face recognition technology. That means application of artificial intelligence. So that is where we can enter through Python, of course. So whole thing, whole saga is very interesting. So how they control everything, how they do everything, whether it is ethically, politically correct is or not is something different. But I can tell you that if you have this data, if you have this curve, certain things like that, forget about China, forget about India, forget about Pakistan or America or whatever. I see data, and the data, what data can tell you, that's what you do with lots of data. Of course, you people are more experienced than me, and you can tell a lot of things than me. But to me, it was interesting anyway. So that was that anyway. And things are the repetitive works. We try to see lots of other things. And if you are not tired, I can tell you a little bit more about. I want to tell all those things, but of course I can tell you some other aspect for 5 minutes. Okay. See, I told you that if you have data, raw data, you can import through pd.read CSV function, and you can plot, you can infer whatever you want to. But in some cases, see, for the coronavirus, the data, the most, I mean, kind of presentable form of data and the most regular updated data was in the other side. You know it. It is worldometers. Okay. So if you go there, I just show you first. If you go there, this is another site. Okay, and this is the most authentic site. Authentic in a sense, people follow it. At least the media follow it. Okay, the media follow. So if you go to this, you have every one of us have seen this site. So it is giving you the latest. So so 7,115,000 this thing, 71 lakhs. So by all country. So these coronavirus cases, and deaths is so far 4,06,000. Recovered is this. So the cases are this. So you can't see raw data here. They won't show you, give you the raw data. These data are presentable in this form. But now you want to, you can think that, okay, whatever data they gave, I'm not satisfied. Whatever presentation they gave, I'm not satisfied. I want raw data. I will analyze on my own way. So for that, there is no other way. I mean, this data plotted, they have plotted everything. They have done everything. But here you see a table. Yeah, the present a table. here, but the table is a recorded form. You cannot capture the table. It is not a Excel sheet and it is not a raw file that you can download it. You cannot download this table. So what you did is that basically this is the whole thing is a HTML file. Okay. In fact, the entire this website, this is, if you see it is, if you see view the page source, if you see the view the page source, you will see this as a HTML. Right click on your mouse on any site and you will see the source file. You can see this is a source file. It is, if you are not used to it, you will not understand. Perhaps computer science people will understand. This is, you see the HTML file, hypertext. And I want to plot it from here. I want each columns, each rows, and everything. So whether my machinery can do that, okay? This thing is called as to, I mean, at the surface levels, I'm telling you, it's a very sketchy way, because one day so many things will be, I mean, so jam your thinking. So this thing is called web scraping. So this is web scraping, the way you extract tables and information from web, basically. Once you have a real data file, it's okay. So, okay, so now you go to here, and so it is. So what you do is that first you follow these steps: import pandas as PD, right? Then you have to, there is a module called requests. This is inbuilt, that is not in Panda. Import requests. So this is for ethical reason and to check whether this website will allow you to extract data, because there are some secret files. We may not go to Pentagon or Indian Army site and can extract data, can download data. Even if we can see that, we cannot download that because they won't give you the permission. But in some cases they give permissions, particularly if you see all the Wikipedia sites, they are very good. They are very all free. They are open sources and they will allow you to extract data from them. But I would have to see that whether this Worldometer site will allow me to extract data first. So that is done by the requests module. Okay, import requests. And then there is another high fine thing. This is called BS4. This is another, actually, like Pandas, this is another package, BS4. BS4 is beautiful soup. The name is very interesting. Beautiful soup. Why it is soup, you will understand a little bit now. BS4. Okay. If you go to your Anaconda, you can actually, if you want to work with it, you can actually download this, install this BS4, Beautiful Soup 4. Anyway, and I write this quote unquote site address. Quote unquote means it is a string, and say I name it with a variable URL. Actually, URL is, it is called URL, uniform resource locator or something like that. Okay, universal resource locator. So this site address is called URL. So it is a short name. So I now print. Okay, now I run this. Now I run this because I won't write every time these big names. So I rename it as variable URL. And now I print this. So it has taken. It has taken. Okay, so it has taken. Okay, now this your requests. So what request is that in this request module, you have a get function. You ask whether I will get it or not. So you get and write URL inside. So you run it. Okay, and you see the page. I rename it as page. Okay, and I run it, and the response will be 200, for example. And it is, I mean, if you search the literature, this response code, that means is 200 means it is you can download data. That means it is permission is given. If the response code is say 403, 400. So the I was talking about here. So you have to request. So request.get and the URL. So you request the page, and the page it shows the response is shows 200. That means it is permissible. And the numbers 403, 404, certain numbers, they are not permissible. You can see the literature or the manual here. So page.text, what is there? How does it look? Page inside that, what is the text file? Let's see, because data is your text file. So say, so the entire the site, entire the website, this looks kind of all, it's a jungle of things, all these data and things like that. Here, from here, I have to extract the table. So now you know have to make a soup out of this. So BS4 is the package, external package. Under that you have a beautiful soup, capital B and capital S. So there is a beautiful soup is a function. So you give this oh, I give it to rest of that page.text. Res, what is res? No, I have to give it page.text. Anyway, let's see here. It has to be page.pa page.text, and that is a typical format LXML. Okay. You may not have to know all the things now, but later when you see will do the work, you will actually eventually get to know. All I want to tell you is that it is possible to extract a table from a presentable from a website. If they give you the permission, you can download the table in the form of first a text file, and then you can convert it to a beautiful soup. That is soup you can manage. So, and the name you give soup. Okay, run. So run it. And the now you see in soup is to show you in a more structured form. So beautiful soup and page.text, and it is a format. You don't have to know this now. And you rename it as a soup. Then table equal to table soup.table, and just type it, and then you print this and this. See the tabular format. So these things you have to know a little bit about these, how a table is made in HTML. If you not very much, but a little bit. If you now know this, see table is a class, table class, and then the thread tr is the something that begins with table. Okay, table rows. Okay, tr for table rows and so on. I'm right here now. You can. I mean, I fear that when I am out of the network, and 1 or 2 minutes, I'm just over. I'm just over. It is hanged. Now it is my system. My Anaconda is hanged. And okay, let me tell you. Just a minute. Just a minute. It will come. It will come. Please ask me question in between if you think so. Okay, it is not coming. Oh, let's see. I reload it. Let me reload it. Well, yeah. I don't know why it is behaving this way today. Okay, it has come. It has come. Reload it. Uh, mm, 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 mm. Okay, so I come to the end of part. Yeah, in part. Okay, just want to tell you that it will show the beautiful soup will at best show you. And if you know HTML a little bit about, not much, then you will understand these. These are all talking about tables. TR is table row. I think TH probably horizontal or something. I don't know. I mean, this begins with TR and /TR. They begins with TH, ends with TH. This is all about decoration of tables and the data and everything. D for data, I think. In between the AC, the something here you see. TD/TD. That means data. This inside this data. TD for table data. Okay. Now we will use that. This much is enough. Now we will use that. Oh, it is not going. Okay, since it is objecting. Anyway, so you can find where is the row, where are the rows. Table dot, you can also write table dot find all rows. You can find all rows. You can print the rows. Okay, you can print the rows only. What are the rows of the tables? But in the HTML format. Now you can also extract these things in a certain way. I think it's not necessary. All the data, TD is data. Okay, TR dot find all. Inside that you write quote unquote data TD. Wherever there you will see TD, it will fetch that, and you now collect this. That text data is text. TR dot text for TR in TD, and you call this as row and print row, etc., etc. If you can now see that, and you'll see all the rows are in this format. So now you can see this North America, South America, Europe, and all the data points. Little bit better format. You can see that. And moreover, this thing is you see this square brackets. Whenever you see the square brackets, you can be excited that okay, it is something like list or array. So it is under your control. So last line. Okay, so yeah. So you do that. You can type the what is the 1th rows 1. What does it show? Tag element. Okay, fine. What is this? TD data and this you can also see that. You can see row, etc., etc. So this thing you can row itself. It's a list, long list, and inside this there is lots of things. And you can type row is a list, so it's a list. Good. And you can see you want to discard this thing first element, then the next element. You want to only have the data, and at the end you see at the end it's not actually going. It's not actually really objecting today, this Anaconda, because it's becoming so heavy, so much of data. Okay, my memory of the computer is low. Now it shows list, and now you see row 2 colon -4. -1 is the last value. -1, -2, -3, -4. Last 4 values you want to discard. See, these values I don't want. Some empty things, all, etc., etc. I don't want that. Okay, so if I want to see that, run this, and it will show you all the data. Now you do whatever you want to do. You can plot that. You can do whatever. Okay, so this is I wanted to tell. Of course, the web scraping is a little more difficult to understand initially, because you have to understand HTML format. You have to understand the protocols. You have to understand how to figure with beautiful soup and the request, etc., etc. So that is I'm telling you that it is possible. If you want to work in data science or big data, it is possible to extract take data from the downloaded file and manipulate it and do whatever you want. And also you can extract data from any website, provided they give you permission. So thank you. I now end. Thank you.
Thank you, sir.
Okay, thank you. Okay.
Because I think they are overloaded.
Overloaded. I know. I mean, I could have.
And
Yeah,
This is
talk
a
to-
long session because this is a 7 days session.
yes, yes, I understand. I mean, in this lockdown
And
period, and
past 4 days they are loaded with SPSS, and there are
Ah.
so many things.
yes,
অতনু
হ্যাঁ ম্যাডাম বলুন।
এটা কি শেয়ার স্ক্রিনটা কি
স্যার 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 শেয়ার স্ক্রিনটা একটু অফ করুন স্যার।
আমি শেয়ার স্ক্রিন অফ করবো, রাইট? ওকে,
হুম।
just okay, I see. What I do